Hello and welcome to R&D Math, and today actually I'm going to give you some introduction, give you some hints for your assignment. Now this is the assignment 1.1 question. Now here I assume you are reading the book. There are 4 scales of measurements: nominal, ordinal, interval and ratio. Now these are going to be your solutions, your answers for these questions. So I'm not going to answer all of this question. I mean, I'm not going to answer any of them. I will only give you hints, right? Only hints. Now let's talk about nominal. Nominal means like things like actually name, right? So like, for example, gender, male or female. That's a nominal one because there is no order, no interval, no ratio. You cannot say male is twice as female or anything like that. It's just a label. So that's nominal. And when we go ordinal is, yes, there is an order. So there is an order, but they do not divide, or they do not indicate the magnitude of the interval between the measures. For example, some grades of achievement. That's an order, but you don't know the magnitude. So for example, this one, grades. For example, you can have A, B, C, D, you have 7 A's in a class and 16 B's, 18 C's and 5 D's, let's say like that. Now, in this case, you don't know anything about these 16 B's. You cannot order the people in 16 B's. So that's an example for that one. And interval actually, in interval case, it's possible to say possible to compare how better one measure to other. But the interval, a critical thing to remember, interval does not have no true 0 point. Ratio, yes, you can compare, but as well as there is a 0 point. Now I must give an example for this one to understand, because they looks like similar. For example, if you take the best example available, well, it also appears in this question, but I have to tell that. So in this one, the best example is temperature. If you take temperature, and if I tell you today is 0 degree Fahrenheit, and if I ask you question, and okay, how about this? I'm telling you today is 0 degree Fahrenheit and tomorrow will be twice as today. Now this question does not make any sense, right? Think about this, because 0 into 2 is, it's still 0 in mathematics. So this 0, this means actually this question does not make sense, but it is a nice example. This 0 does not mean there is no temperature, right? If I say the length, for example, if I say length between A and B is 10, then that means there are, let's say 10 miles. So there are 10 miles between A and B. If I say 5, okay, little less. If I say 2, little less. If I say 0, A and B in the same place, there is no distance, which makes sense. So there is no, what we call the measuring amount, distance is not there. So it's 0, it makes sense. But when we say 0 degree temperature, it's not the case that you do not feel anything, right? You feel some kind of temperature, but still we have to go with labeling 0. So no 0 point. That's a good example. And guys, I think that's enough for this example. Now let's go to the next one. Next one, we have, this is 1.2, 1.2 if my memory is correct. The next one, now this one, you have to make a stem and leaf diagram. Now, so you have data set. First of all, see here, you have how many? You should be able to count how many it will, you will need that. So the easiest way to count is you have 1, 2, 3, 4, 5 rows, and how many columns? 1, 2, 3, 4. Like that, count the number of columns, and that into 5, that's the total number of data. Now make a leaf, stem leaf. Now, what do you mean by stem leaf? As the name suggests, you have a stem of a tree and you have leaves, right? This is exactly what's happening in this statistic term. So stem leaf simply means this. You divide by a vertical line, and left hand side you put your stem. So for example, let me teach you an easy way, this fiber that I would do. I would take the first one, 46. So 46, 40, that 10th part is 40. That's your stem. 6 is leaf. And then 63, so 6. Well, it's better to put 6 here, 3, because there may be 50s, and then 31, 31, 49. So you already have 4, so 9, 24, so 2, 4, and then 16 here, 1. Well, I did a mistake. Don't do that. So 2, 4 must go here. It's better to order your stem first, and then 16, 1, 6, 21, you already have 2, 1, 4, 7, 47, so 4, 7, 56, 5, 6, and so on, right? Now, if there is a number repeating, for example, if you had another 47, you write 7, right? That's how you do it. And then after that, I would really recommend you to do this. Actually, you must do this. First, you do it like this, but this is not your final solution. And then, for example, your stem is already nicely rearranged if you were careful about in the first place doing that. But leaf, I suggest you just put it like that, and in your second attempt, see, for example, you can rearrange. Let's say this is our stem leaf. Actually, this is not going to be, in your case, there are so many data, so it's going to be much, much larger than this. But anyway, if this is the case, for example, 1 and 6, okay. Here, rather than writing 4, 1, it's better to write 1, 4 in that correct order. So 1 here, 6, 7, 7, 9, and like that, right? So this is simply stem leaf. Then you have to make this what we known as frequency table. Now, first of all, make a frequency table with 7 classes. So this is kind of a condensed question. It has so many parts in one question. So let me talk about a little bit about classes. In this case, actually, when we say classes, 7 classes. So the number 7, let me go back. Here, what you need to do in your data set, you have to find the largest and smallest. It's easy to find it in your stem leaf. Probably maybe if this is, maybe it's 16 and 60 something going to be, let's see, 60, yeah, 16 and 64, right? Yeah, here 64, I think so. Anyway, so what you need to do, largest minus lowest, and then you divide by this number, because you are breaking your range. So this is actually range. Max minus min is range. Please get used to these statistical terms. Max minus minimum, that's range. And you divide it by 7, and whatever the number you get, so you get some approximate, some point numbers, you round it. Let's say you get 6.8 or something, you round it. Then if that value is 7, now let me help you. See, 16 was your first number, 64 was your largest number, 16, and then, so your class width was 7, so 16, 17, 18, 19, 20, 21, 22. So that's 7 of them. Next one, 23, and then 23, 24, 25, 26, 27, 28, 29. Right? So including those two endpoints, there should be 7 values. So that is your class. That is actually we call it class limits. So 16 to this. So first part of your table going to look like this. And I want you to complete that. And then class boundaries. So class boundaries. Now, what do we mean by class boundaries? So the way to calculate, actually, I recommend you reading the stuff from the book, but an easy way to calculate this, let me teach you an easy way. Look at these two numbers, 22 and 23. What's the midpoint of that? You add it and divide by 2, but it's easy here, 22.5, right? That is the midpoint. And if you go, see your classmates, let me write down one more, 32 something here. So next one, that's 20, the midpoint between those two, 29.1, that is the upper limit of your class boundary. It's always the second row. So the first one is going to be minus 7 of this one, that's 15.5. Like that you complete. Actually, there is a nice pattern if you think about this. 15.5 plus 7 is this, and that's going to be your lower limit of second one. And plus 7 is this. Whatever you get here, I mean, you are going to get this one here. Plus 7 is this, and you will get this one here. Plus 7 is this. Like that, you keep that pattern repeating, right? And then midpoint, that's pretty easy. Midpoint is the, well, actually, as the name suggests, midpoint of this range. So there are 7. So you can, how do you actually calculate? You add these two numbers, 38 divided by 2, that's 19, right? That's the easiest way. And then like that, you calculate your midpoints. And frequency is how many time it occurs. Now, how do you do that? Well, you must, that's the easiest way to deal with. You can calculate it. For example, if this is my final stem leaf, frequency of 46, frequency of 47 is twice, right? Like that, it may be more than that. Like that, using this, you can easily calculate that. And what is the relative frequency? Now, you know what, let me get simple example. Let me get a simple example and teach you relative frequency. So let's say if I ask my student about eye color and frequency, and let's say we have blue, brown, and green. So let's say I have 20 students, 45 students, and 15 students. But this is frequency. Now, what is relative frequency? Well, that's as a percentage. So for example, first you have to take the total. So 45 and 15, that's 60, you have 80. So 20 out of 80, 45 out of 80, 15 out of 80, but you have to make it into a percentage, multiply by 100. Oh, 20 out of 40, that's 1/4 or 25. So this one either can be, okay, for example, this result here can be either 0.25 or 25%. Both of them are acceptable. So in your case, what you need to do, you need to calculate the total frequency. Well, that's going to be the total number of data. And for example, let's say this is occurring 10 times and this is 50. So this is going to be 10 over 1/5 or 0.2 or 20%, right? Like that. I think that's enough help with that one. Now let me see. Yeah, and then let's see. Okay, histogram. Now in this case, this is pretty easy, guys. So you have to use your this one, class boundary. So what you need to do, you need to actually, so these numbers starting from some point, let's say 15.5 to next 22.5, and whatever, whatever the number, the percentage, that's the relative frequency. So make some good scale. So it must look like this, something like that, or something like that. I don't know. So depending on your data, so you simply complete that. And the shape, the shape, I recommend you reading stuff from book. You have this shape or you have these shapes, I'm not going to tell you the names. So most of the data to the left in this case, to the right in this case, and you have special names, bell shaped and normal distribution, things like that. So do a little bit reading on that. And yeah, now the question part E, that depends on again everything you did. So that's the idea of why doing statistics. So depending on, let's see, let's read the question again. So this question is about driving under influence of alcohol. Okay, so after doing this analysis with the help of this statistic, think about this, like what group has more influence? And it may be the case that we can increase their insurance, right? What age range? So between 20 or I don't know, depending on your analysis, if you do it correct, everyone should get some, close answers. And you are welcome to put your thoughts in that, any additional thought as well. Okay, I think that's enough for this video. Now 1.3, I will do another video. Thank you.